Good afternoon, everybody. We are now going to be talking about legacy systems. My name is Kevin Feasel. I am a manager of a predictive analytics team out of Durham, North Carolina. I'm also a Microsoft Data Platform MVP. I have a blog, Curated SQL. The idea behind Curated SQL is that I want to try to find and link to 5 to 10 interesting blog posts per day. Interesting can be database development, administration. It could be security, Hadoop, Python, Power BI, R, this ever-broadening data platform space. That's curatedsql.com.
Thank you for linking to my blog.
You're welcome. I've linked to like half the people in this room. That's what I do. So, legacy code. There are a couple of neutral connotations of what legacy code is, and at its simplest, it's code that I inherited. The guy who got hit by a bus left me this code, now I have to deal with it. Or who won the lottery, or who got hit by the lottery bus. That's the most ironic of all. It's just older code that I have to maintain. Yeah, the system was written in 2000. It's still a good system, but it's written 17 years ago. Nobody ever talks about legacy code this way. No, it's never that nice. Instead, they got hit by a bus. Turns out he didn't write any tests for that code. The code barely works. It's rotten, like a rotten foundation on a house. You sneeze the wrong way and everything collapses. You look at it the wrong way and server falls over. You're spending hours every week trying to fix things, and as soon as you fix one thing, it broke something else, and you're just running around trying to fight that fire. That's my definition of rotten code. That's my definition of legacy code. And throughout this talk, we're going to look at ways to try to patch that legacy code, and specifically legacy T-SQL code. Because this stuff demotivates you. If you spend day after day just fighting fires over and over, it burns you out. There was no joke in that. That was not intentional. You will spend a lot of time trying to debug awful code. And that last time that you look at the 9,000-line stored procedure that has 5 levels deep of nested cursors, and Jonathan knows the one I'm talking about, it just kills your soul. Even fulfilling a simple business request. Oh, I just want you to change this output to make it slightly different. Yeah, that'll take 4 months. No, but I need it tomorrow. Okay, 4 months from tomorrow. And then after you leave, after you get hit by the lottery bus, your successor is like, man, that stupid Kevin wrote this 5 nested layered cursors and stored procedures. Or, my favorite, actually post-nested cursors 5 levels deep, was the stored procedure that called a stored procedure to generate dynamic SQL to call another stored procedure that called more stored procedures that generated more dynamic SQL that read from a table which had SQL, so it would build up more dynamic SQL to give you a result set. About 30-some thousand lines of code. Strangely enough, the thing broke a lot. It's weird how that works. So let's give a little bit of TLC to this code. And I have a structure to this. I'm going to start off by telling you about what you absolutely have to have in place before you start screwing around with code bases. 2 prerequisites. The first one is source control. Absolutely need source control. This is the year 2017, so I've been told. We probably need source control at this point. And like copying your scripts into another folder on a share drive somewhere is not really source control. Use a real source control system. Git, Mercurial, Visual Studio has Team Server. That's a working source control system. Subversion, CVS, use something ancient. You could use SourceSafe. It's still better than I copied a folder to this share drive like 3 months ago and people have been making a bunch of changes since then. If you have somewhere, ideally someplace that your developers use, where that code can go, this saves your bacon. Because eventually, as you're trying to fix stuff, you will accidentally introduce a major problem. You will introduce some breaking change and have to go back to that old version. Having that old version as source control means, well, okay, I'll just revert to the last version as opposed to, well, I'm going to be up till 3 a.m. trying to fix this mess. Also, tests. This is kind of difficult for databases because a lot of test methods were designed around applications that were stateless. You pass in variables, you pass in these parameters. The function does something, it returns an output set. That's really easy to test. That's just simple black box testing. Once you introduce databases, oh, well, my change here modified the structure of the database because I've changed data in there, or the outputs of my function are entirely determined upon the inputs of this system that I don't have full control over because I'm on a development team of 150 people. This makes database testing a lot more difficult. So there are a couple of test projects, test things that you can use to help yourself out. One of them is T-SQL T. That is a unit testing solution. Redgate has a UI on top of it, and this otherwise T-SQL T is an open source product. You can take it, you can install it, you can run it locally in your dev environments, and it'll allow you to mock out your tables, your views, your stored procedures. So that's for more unit testing. For more integration testing, Visual Studio has database test projects that have been around for a decade at this point. I think they first came in 2008 as part of DataDude, which was an awful name for a product, but I still like database projects. These test projects, they're C# code and resx files. So you have a UI to allow you to write T-SQL statements, and then ADO.NET calls those T-SQL statements. This is great for integration tests. It's not for unit tests, really, but you have things that, well, if I make this change, if I call this procedure, I'm expecting these outputs to occur, and I need that output to occur within n seconds. I need to make sure that I get 2 result sets back, that the first result set looks like this, the second one looks like that. This is the type of thing that a Visual Studio database test will do better. So you might try out both. I have links to both of them. Let's start modifying code. The easiest, lowest risk changes that you can make is simple. Format your code. Make sure that you can understand what the code looks like. Because at the end of the day, code is for humans as much as it is for compilers, or in T-SQL's case, interpreters. You spend more time with that code than your system does, probably. You spend more time looking at that code. It's your job to make sure that the code actually works. The interpreter will just take that code and happily do whatever it says. Your job is to make sure that it's saying the right things. Let's start by looking at a demo. Now, here's my first demo. This is, actually it's kind of cleaned up from what I originally had. A lot of these are Law and Order style ripped from the headlines. I've changed some things to protect the guilty and make it a little bit more pedagogically concise, but I've seen some pretty awful code. Here's an example where this is just a T-SQL query. Don't worry about what the query does. Worry about the fact that you have a column here and a column here, and it looks like there's one here, and I guess there's one here, and I'm not sure exactly where this thing came from. Why is this thing indented 4 levels? Maybe there's a reason. We have messes of parentheses where it's hard to tell where one thing ends and another thing begins. We have, coming down, you might see the arrows. The arrows indicate tabs. This is one of my little bugbears. Somebody went from tabs to spaces, multiple developers working on this thing. We also have things like this subquery. And you say, okay, that's an interesting subquery. And then we scroll to the right. We find out it's actually multiple subqueries. But it's hard to tell, except there's 2 where clauses. I don't know, somebody might have just not been all there that night and somehow put in a query with 2 where clauses. Maybe the thing doesn't even work. I don't know. And this is just within a few lines of code. This is like 70 lines of code. Imagine this in the middle of an 8,000 line stored procedure. And by the way, if you want the full list of my airing of grievances, I have them here if you're interested in seeing them.
Tell us how you really feel.
Yes. Well, the best part is many of my formatting standards that I've come up with now are based off of a 50-some page formatting document that we have at work for all database engineers. You're supposed to read this 50-some page document and align your code to that. That's how strict they are. I follow that most of the time. 40-some pages of it. So here's a different version. First, consistent formatting. I did use spaces. If you use tabs, if you prefer tabs, cool. Use tabs. I have no beef with them. Although there was that article that came out from Stack Overflow that said that people who put tabs in make more money, or excuse me, spaces make more than tabs.
Yes, but tabs take up fewer bytes on your disk, so you're saving space. So I mean,
Randolph says that tabs take up fewer bytes. So that's an important consideration if we're back in 1988.
having used Azure, it gets expensive.
Randolph makes a point about Azure. It is a good point. All right, so
X is a square.
Now we're back in 88.
anyhow,
That's a TV joke for Americans.
yes. Anyhow, we have everything has an alias, and I alias it with as. Some people like to say basic ID equals this. If you do that, cool. Just stay consistent with this. Pick a format. But definitely if you do this, put in as. Yeah, technically it's not required. You could put in basic ID like this. But then if somebody accidentally adds a comma later on, this is a valid query. It's just that you're not going to like the results necessarily. So when you need to alias, when you need to have multiple lines, like maybe in a case statement, go ahead and do that. Sometimes you may not need multiple lines. Like down here, I could arguably put that on multiple lines, but I think it flows easier. It's easier to follow along. What we end up with, because of appropriate nesting, like joins one level deep, but then the on clauses are one more level, we can easily see that there are two subqueries in here, and also that this is a pretty nasty where clause. It probably isn't going to perform very well on a large enough data set, but whatever. At least it's easier to see that just from looking at this than seeing the mess from before. And the best part, you can use a formatting tool to do this automatically. Like I can hit Control-K, Control-D, and notice that it changed all my tabs or spaces to tabs because I secretly prefer tabs. So you can set up formatting tools to do this. The one that I use is called SQL Complete. It is by, let me make sure, DB Forge. So this is DevArt. There are other tools. Redgate has a nice tool as well. There are other companies that have additional tools that do a great job too. It's probably worth buying. Usually they're only about $50 to $100. So I ended up just paying out of pocket for it so that I could use it for personal purposes. But absolutely worth it. The first time you see a nasty query that you can hit Control-K, Control-D and be like, yep, now I understand what this query is. Ugly. But it's ugly for different reasons. Yes?
It's not integrated into the SQL environment, but probably a lot of people here use Notepad++. And there's a plugin called Poorman's T-SQL Formatter that does this. And whenever I'm dealing with messing with a ugly, gnarly looking query, I'll just pass it through there real quick before using the back end to save.
Yep, so Notepad++, there's a Poor Man's Formatter, there's PoorSQL.com, which is also where Jonathan learned how to write T-SQL. That's why it's so poor. Oh, circle gets a square.
So he didn't tell you that. That's that big thing talking about he wrote. But
I didn't.
Apex SQL is free.
Apex SQL has a free version. DevArt has a free version. I think Redgate's got a free version.
And they plug into the management.
Yeah, all of these do.
It's a trial. Redgate's SQL Prompt is a trial.
Okay.
Apex SQL is free, but I've had a lot of problems with it integrating with the latest in Visual Studio.
Right. They'll take a little while to do it. Like DevArt has their free version as well. The difference is the paid version will let you do more things. They have more specific rules. And it'll take usually a couple of months before they can pick up on the latest stuff within a version of SQL Server.
The nice thing about the SQL Prompt, just for anybody who's looking at it, we just recently bought it, is that you can actually export out your styles and share it so that way you can have a standard SQL formatting across your entire text.
Yep, that helps you with one of the big benefits of formatting SQL. You can start formatting Holy Wars. So you actually do, just by formatting T-SQL statements, just by making sure that everybody understands what your code is supposed to do, that can seriously reduce the number of bugs. it can make your life a lot easier. So much easier than you'd think just by saying, oh, just make your SQL look pretty. But there's a huge advantage to it. And I have some recommendations, but including save time by using a tool. But frankly, you don't have to take any of my recommendations. You can follow your own. Do it as a team. Figure out what you as a team are willing to do. I've compromised on things because the other database engineers who I was working with preferred it a different way. And in that case, cool. As long as everybody is on the same page, you can follow it, you can understand it. There's no inherent best way of writing T-SQL, except exactly the way that I do it. So that's formatting. This is like baby stuff. Now we're getting into, you've got some pretty looking code. We're going to simplify it. And my philosophy on this, I stole from one of the Python cones. And that is that simple is better than complex, and complex is better than complicated. There are things in T-SQL that are unnecessarily complicated. Cursors and while loops are unnecessarily complicating. And I'll show you a great example of that. You may have chained stored procedures where you've got temp tables that are holding state between these procedure calls. That's really complicated to understand. It's difficult to follow. If you're trying to change one procedure, you have to figure out what are all the procedures that could possibly call this thing. And by the way, they may not be in the same database or even on the same server because of the joy of linked servers. Yeah, let's not go there. You may have processes where just by running the thing, you change state. So it's an unrepeatable process. I had to deal with something that I'll show you later on with design, but there was a cost processing system that by virtue of running the query that says, tell me what I need to do, will modify the data so that the next time you run that query, those rows won't show up. So if you're troubleshooting, like, why didn't this row show up? Okay, well, let me enter it into the queue, and I'm going to query it. Yep, it's right there. So system should work just fine. Go ahead and run it again. Well, it turns out they can't run it because I've already changed the data. We can take advantage of the tests that I set as prerequisites, and that's like 9 months of work that I put into about 45 seconds of slide time. But once you have that safety net in place, you're able to start taking more and more risk because it's really not that risky. Because you've got tests in place to say, this is how my system behaves now. All I'm doing is trying to refactor code. I'm not changing the way the thing works. Inputs still come in the same way. Outputs still go out the same way. It's that black box in the middle that I'm changing and trying to make it easier to live with. So what I'm going to do, instead of going through my slides, let's just walk through each of the sections. The first section here, I'm going to, again, note that this was ripped from the headlines. I have a fact table. This is data for a digital marketing system. And it's clickstream data, and we have cost and revenue. So revenue, we collect by day. Cost and click data, we actually have two separate sources of data. But very helpfully, we have a bit flag that says, we'll use the first source or we'll use the second source. So I'm going to enter some rows into that fact table. And I just want to point out that sometimes we have the first record, sometimes we have both, sometimes we just have the second, sometimes we have neither. So it's a little bit complicated what we have, but we do have a rule that tells us which of those sources we want to use. Here's a query that is formatted fairly nicely. It's a cleaned up version of a real looking query. And don't focus so much on what the code is doing here. Kind of try to get your eyes pointing different directions and just focus on the colors. There's a lot of pink. There's a lot of blue. All these pinks are function calls. All these blues are syntax bits. There's relatively little black. And where there is black, okay, we have is null of some measure, but we have a lot of this. Case when use source 1 then something else. Case when uSource equals 1. Case when uSource equals 1. We're going to see it. Here's a version. Here's a version. Here's one. We have all of these same things over and over, the same bit of code copied and pasted. We have this thing called a conversion rate. And the conversion rate is several lines of code with nested case statements where we've got all kinds of stuff going on. So I can run this. And it works. This is a perfectly functional query. It gives me back perfectly functional data. And I'll run it again just to grab the execution plan because we'll check that out in a moment. Because I want to show you guys the power of the apply operator. This is my favorite T-SQL operator. And I'm going to insert the same data into the same fact table. I'm going to run with actual execution plan another query. So first thing is first. I want to show you guys, memorize all of these numbers. They're all the same. That's pretty cool. The numbers are correct. Second, memorize this execution plan. Excellent. It's slightly different. But the difference is a constant scan. It's a 0%. It's 0. It's nothing. It's nothing. 1%. No problem. Let's look at what the apply operator is actually doing here. First, I'm going to jump down to the from clause. So from dbo.fact, cross apply. First thing I want to do, let's take all of these is nulls and shove them away somewhere. This is like putting the dotty ant in the attic. We know that it's still there. We just don't want to think about it. And I'm going to call that no null. Now, incidentally, you might be saying, wait, if you sum values, if this is null, it will just ignore that record. And I will say yes, but there's a little warning message that pops up in Management Studio that says that there were null values and aggregation and they were ignored. Well, we had an old application, and that old application would take that warning message and basically turn it into a second result set. And then the calling code would say, wait, you have 2 result sets. I don't know what to do here, and would throw a hard error. So this happy warning that says, you don't have to do anything, broke the system. So the end point was, well, let's just add is null everywhere. And it worked. And now it sits here. Okay, so that's our first apply operator. The second one, I want to say, all those times I copy-pasted, use source equals 1, then this. Well, let's sequester it away as well. If we need to use source 1, then we'll have click source 1 and cost source 1. Otherwise, we'll have click and cost source 2. I'm just going to call those clicks and cost. And the name of this apply operation is US1, use source 1. Notice with the apply operator, I don't need a from clause. I'm not hitting a table again. This is all happening as part of the stream of data that's coming through that you see in the execution plan. This is happening in memory. And it's at extremely low CPU cost. But what it allows me to do is come back up here and say, the sum of orders, sum of order revenue, sum of this, very easy queries. Conversion rate now becomes easy. I was able to zoom in, and now I can say, oh, I've got a few guard clauses, but frankly, all conversion rate is orders divided by clicks. That's it. Yeah, there's these guard clauses just in case the numbers don't work out quite right, but that's a conversion rate. Now, I can look at that, and I can say, well, I think I see your problem right here. You've got clicks over orders. That's not conversion rate. So it's much easier to see a problem in a query that would still run correctly, but is a mathematical error. You can see your work much easier. And if I take the 2 queries, I just showed you a comparison in terms of here's an execution plan, here's an execution plan. Well, turn those on, turn off actual execution plan. If I run these two things, no real difference in execution time and no real difference at all in I/O. It's doing the same work. It's doing it the same way. It's just giving me a result that, as a human, I can understand. Questions about apply? I have an entire talk on it because I love the thing so much.
I know you do, and I want to watch it.
It's actually a cool talk, too. It's my shit for the file.
Thank you, Jonathan. Jonathan says it's a really cool talk, and I agree with Jonathan. That's a really cool talk. Tracy agrees with Jonathan. Basically, everybody's in agreement that it's a really cool talk and that dinosaurs are cool.
So why are you blushing, though?
Why am I blushing?
You actually are.
I think it's because he didn't expect a nice compliment out of Jonathan.
Hold on.
Let's fix that.
Triangle gets the square. So let's talk about dynamic SQL. Dynamic SQL is useful. In some cases, it's vital. In some cases, it's utterly unnecessary. Here's an example where it's utterly unnecessary. So we have a statement that really all we want to do is select from some table and say that if some variable is equal to 8, then add in this AND clause. And maybe it came in a stored procedure call where some var is the stored procedure input. And somebody found out that there's a parameter sniffing issue because if some var is equal to 8, then there's this awful performance scenario. And so we ended up wrapping it in dynamic SQL and turning it into an ad hoc query that runs so that we can generate separate execution plans. And then later on, somebody said, you know what, I can also add this in. I am just so storying the crap out of this. I don't know if that violates Carlos's cardinal rules of no just so stories. But we don't need this. Instead, we could just as easily write a query that looks something like this. And if you do have a parameterization problem, you don't necessarily need dynamic SQL to fix it. You can use one of many other methods. I'll give you a couple of them just right offhand, since somebody did have a point about parameter sniffing and ways to fix it in the set of things that we want to talk about. One of those methods, I'm not going to give them in any order. There's no this is better than this, because we can start a debate on that. Option recompile on the entire procedure. Adds more CPU cost, but you know what? It works. Option recompile on the affected statement. Again, adds more CPU cost, but it will do the trick. You can take the input parameters and then declare variables inside the procedure call and set the parameter values equal, so set the variables equal to the parameter values. And that way the optimizer doesn't know what the input values were, so it has to essentially optimize for unknown. Optimize for unknown is another way of doing it, which is also optimize for mediocre, because you'll never get a good statement out of it. You'll just get the, whatever.
We have somebody at our work that got optimized for unknown. It's great.
Tracy points out that there was somebody whose name will remain unnamed here because I don't know if anybody's ever going to hear this. No, it's not Jonathan. It was said that Optimize for Unknown was fantastic and the best thing ever, and I know who Tracy's talking about, but we're not going to, no names here, no names. Optimize for Unknown is acceptable, but it's not necessarily fantastic. But, it's still workable. It may be that this is the thing that you want. You could also use a tool like Query Store to say, I want to pin down to a particular plan. You've got a few different methods depending on whether it's one query or a bunch, and how frequently and how much leeway you have in changing the query itself. Because you could also rewrite the query to not suck so bad. That's always an option. And considering that I'm giving an entire talk here about rewriting queries so they don't suck so bad, that might be my best preference. So speaking of terrible, let's talk about cursors. See how I just did that pivot there? I have two tables. I have a temp table called temp1 and a temp table called temp2. And I have some values. And you'll notice that temp2 has a couple values here. Temp1 has just one outside of ID. Basically, think of temp2 as having a foreign key relationship with temp1 on temp1 ID. Maybe it's a child table. And I want to find and build a comma-separated list for each row in temp1. What are all of the temp2 values that are associated with it? So like this row here, number 1, is going to have Z, Y, and W, or Z for our English impaired. So I have a comma-delimited list. That's what I want to build up. Here's the cursor version. And if I had about an hour and a half for this talk, I would, in painstaking detail, talk through, give the English version of exactly what's happening with the cursor. It takes like 5 minutes to walk through this, so I will spare that to you. But we have to declare a bunch of variables. And I'm creating a table variable here. And I'm declaring a local static read-only, forward-only cursor because I copied it from a website where they knew exactly what was going on with cursors. I just copy and paste cursors. I don't actually understand them, and I consider that a point of pride. Local and forward only. Local and forward only, those things I kind of know about. I can make up the rest. But I don't want to know about cursors. That's my point. I want to get rid of them. What we're doing is we're grabbing each row from temp1, sorted by ID. And for each one, we'll grab the ID and value and fetch those into variables. And then we have another cursor. Loader. We have another cursor here where I need to grab all the records from temp2. And I'm going to append each record in temp2. I'm going to append that text string with a comma after each one. And by the way, I need to remove the final comma. So what I would have is basically Z, comma, Y, comma, W, comma. And then here I've got some code to eliminate that last comma. And I end up with my result set. And I can select it. So my result set gets inserted into the temp table, temp values, table variable, temp values, and I select from temp values. That goes from line 106 at the bottom, hop it up all the way to line 21. That's 104 or so lines of code just to write that. By contrast, set-based version. You say, okay, well, we're going to use the combination of the stuff function and for_XML path, and we're going to grab all the values from temp2, grab those specific values, prepend a comma, but we're actually going to slice off the first comma. So what we end up with, starting at line 109 to line 131, that's like 20 lines of code. But we run them, and they end up giving us the same values, which is nice. Even better, if you're using SQL Server 2017, there's a string ag function. String ag function, I say, okay, from table 1, join to table 2, aggregate all the values in table 2 and give them commas.
That's worth an enterprise license.
I'm sold.
You don't even need enterprise. You can do it in Express.
But it is a reason to upgrade.
It is a huge, yes, and also trim. How you no longer have to L trim and R trim, it's just trim. That's worth an upgrade by itself.
It's like Microsoft finally adopted the ANSI standard.
It's like Microsoft looked at Access. But yeah, this is simplifying it even further. This is kind of like the true set-based option. The one before was the thing that people came up with using an interesting hack from the for_XML path functionality. I'm converting it to XML, but it worked well. It was a fast version. This is the appropriate set-based version. Hey, it's a function, yeah, but it's an internal function that is very fast. Next up, Again, this is ripped from the headlines. I have a set of data. So I've got customer IDs and dates. And for each customer ID, notice I have IDs 1 and 2. I've got a set of dates. Maybe those are events that happened. And I want to break this out by the hour. I copied and pasted this code from production, and then I changed a couple things around. Every hour of the day, they're saying, okay, when the hour is equal to 0, then convert this to a day, and then add 0, 0, 0, 0, 0, 0, and then convert all that, cast all that as a date time. Oh, by the way, right below that, we have a count. So I need a group by clause. This was a production thing. I got rid of this thing. It does give you the correct results as long as you don't have any copy paste errors. Like, woe be upon you if you accidentally said 10 down here. And by the way, you were copying and pasting, so you would have changed that to 10 as well. Then you've got problems. So let's do that the less problematic way. I'm going to run this. Now, it's not 40-some lines of code. So, if you get paid by line of code, then that last one probably is better. But this one, we're using, I consider this a little quirky. It's difficult to sell this as simplification by itself because you have to understand how the date add and date diff functions interplay. What we're doing is, okay, let's give me the number of hours between point 0, point in time 0, and now. And then add that number of hours to point in time 0, the beginning of time, which was in 1762, I believe. That is when the Earth started. So,
Earth is also flat.
well, actually, Earth is binary because if I cast it as a geography, it's stored in binary. So it's... Uh-oh. Actually, the Earth started on 1900 because that was point 0 in time. So we're going to cast this. We're going to round it down to the nearest hour. And that's what that functionality does. And it still gives you the same results, just in a few lines of code instead of 40-some lines of code. You're less likely to have a typo in this. But it's a little bit harder for a brand new person who doesn't know any T-SQL to understand what's happening here.
You don't want juniors playing with time and date anyway, so.
They need a template for that.
Randolph made a great point that you don't necessarily want junior people playing with times and dates.
That's why you store those Julian dates and nobody will ever understand it.
Jonathan made me twinge because I've worked at 2 companies that have done this.
Yeah. Nobody would ever even want to mess with it later.
Nope.
It's Julian. Right. Yeah. Salesforce all day.
So don't use Julian dates because they are awful.
Magic. They're magic. Bad magic.
Bad magic. Okay, so using temp tables for updating. I have a fact table, and I'm going to begin a transaction because that's how I roll. I'm just going to leave it open and go to lunch. So.
No, he does this at work.
I have never gone to lunch leaving a transaction open.
He's gone home.
This is true. I have gone. This, I needed to make this very specific, what I have and have not done.
Actually,
While
he's here, though. That's what the phone call was for.
All right. So I've got a fact table. I don't actually do work at work. I can't open transactions. I don't even have Management Studio on my machine. I'm a manager. I have people to do that for me. So I have this fact table, and I'm going to insert some data in there. And what I want to do is I want to update these values, and I want to say anywhere where the value is blank, let's make that C. Because C is the correct answer whenever you're doing a multiple choice quiz. So that's probably the correct answer for this. But I also want to output the values of the record that I updated. So I want to get those numeric IDs for 0 and 4 because I want to output them and see what it was I actually did to prove on my quarterly review that I did something. So I create a temp table. I'm going to insert into that temp table all the values where some val is equal to blank. And fortunately, I don't have to worry about concurrency and the idea of something happening while I'm running this query and thereby modifying the set of results coming back. That is a problem when you're writing code like this. So I'm going to update my fact table. And I'm going to set some val equal to C where it joins to my pound temp table, which is where some val equals blank. So I'll run this.
I thought that was a hash table.
It could be a hash table. It could be a temp table. It's the sign that I use to dial on my rotary phone. Let's talk about rotary phones for 15 minutes. So I select values from pound temp, and now I have proof that I actually did something this quarter. It's a pair of numbers. I don't have any context around those numbers, but I'll go to my boss and be like 0 and 4. Give me my bonus. And my boss, I'm in management. So I'll roll. So I'm rolling back this transaction. But basically, I have multiple statements here. I'm creating a temp table. I'm inserting into a temp table. I've avoided the risk of this update statement updating things that I wasn't expecting because I'm joining back to that temp table. But I have to query that fact table over and over. And if that's a huge table and this is an expensive query, I'm doing it multiple times just to prove to my manager 0 and 4. So instead, I can use the output clause. The output clause has been around since, I believe, 2005. I have my same fact table. I have my same process that I want to do. But we have the inserted and deleted pseudo tables. And I can say output deleted.id. So I'm updating my fact table. I'm setting some val equals C where it's currently blank. I'm outputting my deleted IDs. We have inserted and deleted pseudo tables. I could use either because for an insert statement, you get the inserted pseudo table. For a delete statement, you get a deleted pseudo table. For an update statement, you get both. Inserted is what the data looked like before your change, after your change. Deleted is what it looked like before your change. Based on what I'm doing here, I'm just getting IDs. I could use either pseudo table. So I picked deleted because I'm contrarian that way. And in just a couple lines of code, this is less complex and it's also fewer hits on that fact table. I'm only querying the fact table once, whereas I'm doing it multiple times in my other example. And notice that I left the transaction open because I'm going to Disneyland. Now that I saved 8 lines of code, I just basically saved the company a lot of money. So I'll leave that transaction open. No, I won't. I'm gonna commit the transaction. So that's simplifying code. I've got a bunch of stuff here that is blah, blah, blah about what I was blah, blah, blahing about. So I've already covered it. Any questions about this part before I go on to simplifying design? All right. Basically, as you're modifying code, as you're dealing with those crises, those emergencies, there might be things that you can do to make the code easier to understand. That's at a procedural level. It's at an ad hoc statement level. Eventually, once you've got your sea legs, once you have this stable set of tests, this fairly decent understanding of the process, and hopefully you're getting fewer fires to set or fix, depending on what side of the management fence you're on, we want to start looking at design. We have these tests in place. Design is a bit harder to deal with than the individual stored procedure. Now you have to think about how do these procedures interplay. My changes that I had in that simplifying code, you could do it within a single procedure, and it didn't matter if there was some linked server that you don't even know about halfway across the world that queries your procedure and expects a certain result back. Our changes up to that point were internal. We were still giving back the same outputs, 0 and 4. But now we want to look at that design and say, no, seriously, why do we have this linked server running on Express Edition? I think Express Edition can do linked servers. Let's say, we're going to say it. We're going to roll with this. Running on Express Edition in India is querying this server, and you're complaining about it performing slowly because it's pulling back 200 million rows because it has to query the entire table so that we can filter it down to get the 2 rows we want. Maybe that's not the best design. Let's talk about design. I'm going to talk about it in picture form because design's a big topic. There's a lot to it. And instead of me trying to give you the end-all be-all on design, which I could never do, and certainly not in the few minutes that I have allocated to talking about design, let me walk you through a specific scenario, and we'll talk a little bit about some of the things that we can do to make this scenario much better. Ripped from the headlines, there's this cost log table. Now, this cost log table is by customer. And what we do is it collects data about polling cost for that digital marketing process. So we have a provider, maybe Google, Bing, other providers as well. We have a Julian date that is called JDate. Now, I know of JDate as a very interesting website. That was the only thing I knew about JDate coming in. And then I found out it was actually a date column in here. There's a column called GUID. It's defined as a varchar 50. What does GUID do? I had to ask the developers, what does GUID do? Like, I don't know. It's a GUID. Okay, well...
For transactional replication.
It's not even merge replication, row GUID. No, it's not even that. Actually, it turns out that was the file name that they're using. Other stuff like the send alerts column is always set to true, and there was no code that actually looked at send alerts. If you go look at the procedures, the whole process was a bit difficult to understand because there was some scheduling code that would say, okay, create work, add some new rows. That makes sense. We're going to add the new rows, the work that we have to do. It's weird that a log table is doing that. But then it calls this get for service procedure. So a get procedure, first thing it does is update rows. Now, if you have a procedure that says get, usually you would expect that procedure to be idempotent. In other words, you can call it, and each time you will get the same results because it's a get procedure. It gets. This one is not. It will update data. That's troublesome. The biggest thing, so our cost log table is serving multiple independent purposes. There was the log portion where we stored historical data of when we polled for Google, when we polled for Bing. But then it would also store the data that has to be fetched. So it was a queue as well as a log. That get for service not idempotent. There was a weird get procedure. There's a column named GUID. There's a surrogate date field that was just a numeric field because a 4-byte integer is definitely better than a 3-byte date. To be fair, this was written pre-2008, so there weren't any date columns. There's just like date time, and you can't possibly put a date into a date time column. You have to convert it to an integer, not like 2017 0801. That's an integer that makes sense. No, it's got to be 24,703. Because everyone knows what day that was. Quick, what day was it? Because I don't.
But the Excel stuff is up to 30-something thousand
Excel starts at an earlier point, I believe.
But it also doesn't help.
Yeah. So if you try to paste it into Excel and calculate it that way, now you're going to get different numbers. So simplifying to the design. One of the easiest things as you're going through, I am inserting rows into what feels like a queue table, but I'm storing it long term like it's a log. Maybe those are separate pieces of functionality, says the guy wearing the Apache Kafka shirt. Ask me about Kafka. I love Kafka. But It's two separate pieces of functionality. It's a queue table that says, here's the work that we need to do right now, and then I can delete those rows when I'm done. And it's a log table that says, here's the work that I've historically done so that I can prove to my boss that I actually did something. I watched a procedure run. The get procedure gets rows to process, does not modify data. So select procedures. Basically, if it's something that you're expecting to retrieve data, should not modify that data. Purposefully have other procedures whose entire design is to modify data. Have procedures whose design is to get data. Yes, it's one extra procedure, but in the long run, it makes a lot of sense. It makes life easier to maintain, and if you have a bug within your get procedure, you can test it without having to rip out the code and paste it in and mess around with it and try to rejigger it back into the procedure. It just makes life easier for you. GUID was renamed to file name once we found out that it was actually a file name. And I used a real date field. So the step-by-step process, this is the thing that actually matters. My walkthrough, yeah, I showed a couple of pictures. But the big thing that's important, figure out what's affected in here. I had this cost processing system. First thing I had to do was figure out, what are all the procedures? What are all the calling bits of code? Where's that stuff? How do we use it? And I generated a high-level diagram. Something like that. Except it was on a cocktail napkin. That's not necessarily part of my step-by-step process for success, but cocktail napkins can be important.
Especially if you're drinking when you're drawing.
Yes, that can be a good time to use them. But document the existing design. So take those cocktail napkins and scan them in. Then I found it's easier to do incremental changes on paper because the first design, the first fix I had for this was awful. Totally wrong. And after going through, I'm like, yeah, this doesn't feel right. And the second design was also awful. And then I went and talked to the developers who actually use the system, and they gave me the inkling that, oh, it's two separate tables. That's why this feels awful. I had two separate tables, and the third design was less awful. It was still bad, but it wasn't awful. And by about design 5, it's like, hey, I've got something that actually works. This iterative design is going to be the best way to get from I have an awful, awful design in production to I have a much less awful design in production. So iterate around this. Don't be afraid to throw stuff away, start over, do it again. And then once you've got that new design, now you have a new round of simplification because probably you've got different procedures. Hopefully simpler procedures. You might have more procedures. But if they're doing less stuff, they're easier to read, easier to understand, easier to maintain. Let's remove some obsolete code. Let's delete crap we don't need. Code is a liability. This is something to keep in mind. From an accounting perspective, code is a liability. It's not an asset. Every line of code that you write requires, first, you had to write it. Second, you have to maintain it. Third, you probably have to document it. Okay, in reality, you don't, but you probably should document it. Fourth, the interpreter takes time to figure out what's going on, parsing that code. Fifth, those other developers, once you get hit by the lottery bus, are going to have to learn what it does. Or just hit F5, stupid person who wrote this code. There's more mental overhead all around. If you can write code that's simpler, cool. If you have code that's literally non-functional, get rid of that stuff. I was able to get rid of, I came into a team, I was able to get rid of 20% of the code base. Just delete, delete, delete. Deleting entire procedures, dropping tables, dropping views, because that stuff wasn't in use. I got rid of 150 stored procedures because nobody uses them. I had to restore one procedure because it turned out it was a manual procedure that people run, and they hadn't run it in 6 months, and it turned out 2 days after the release they needed to run it. Otherwise, 150 procedures gone. No one noticed. Let's talk about...
It is funny how obstinate we are about removing stuff, right? It's like, I guess everybody's afraid, and maybe it's a cultural thing, right?
Yeah.
Like you're afraid of your hand getting slapped, right? What did you do?
Well, I liken it to every once in a while you'll see a story in the paper about this person who gets crushed by a stack of magazines because they kept every single magazine since the Great Depression. We are that person. We are that hoarder. There should be a show, Hoarders, just for this. Speaking of hoarding,
the same kind of trend. I work in a place where a lot of the programmers, they don't like to ever delete code. They just like to comment everything out.
Mm-hmm.
And then whenever I go in, I'll just take everything that was commented out and just delete it.
Yep.
Just get rid of it.
I'm actually going to mention that. Yeah. People are hoarders, and here's what I'm going to say. Let source control be your attic where you store all that stuff. It can be your off-site storage facility where you have that couch from college because you know you're going to use it someday. Where you've got those newspapers from the 80s because, man, that stuff's going to pay off any time now. That's where you put that junk that you never have to see again. And just like that storage shed, it's pretty cheap. You don't think about the bill. Source control's cheap. So I have a procedure.
Make sure you're backing up your source control database, please.
Yes, backup source control. Yes, there's something to that. So I have a test procedure, and it has some value. Int equals 25. There's a comment that the code always passes in 25. That's valuable. But there's a check in here. Make sure that some value is not 20. If it's not 25, we're going to throw an error because the code always passes in 25. And then, if the value is equal to 20, if it's equal to 21, this is called logically impossible. Then, here is one of my pet peeves. We just commented out, it's part of a line. Because, I don't know, maybe somebody was testing something 8 years ago and they just commented it out. And then we have this whole if block, which is what Wes was telling me. People will just comment out an entire if block like this. And by the way, there's a comment that says this code needs to run every time. Spoilers. It's not running every time. So you get a call at 3 a.m. Hey, test procedure is broken. It's not working right. Because they're never any more specific than that. The stuff's not working. Okay, I start looking at this, and I see this comment that it needs to run every time. And I'm thinking, is this the problem? I don't know. It's 3 a.m. Let me just change stuff randomly in production and hope it works. That's not the best way to do it. Also, it's really not. If 1 equals 0, Boolean logic has been invalidated. You have bigger problems with this. Actually, again, previous company, there were a bunch of clauses at the very beginning of every procedure. If 1 equals 0, then throw an error. They're like, why is this in there? Oh, well, we need it in here for performance reasons. I forget the exact reason, but it was some cargo cult thing where somebody had read something and misinterpreted it. Now there was this, if 1 equals 0, then do something.
Sounds like something Mark would have done.
It's exactly, that's what I'm talking about. Select 1 from something where 1 equals 0. Spoilers, not happening. If you need an empty result set, I don't know, maybe, but then maybe you have a comment here that says, I need an empty result set. So my final tally, I got a bunch of stuff I don't need. This is the new version that's not horrible. So what we did was, okay, let's delete this, delete that, delete this with angry vengeance, delete both of these. That procedure got a lot easier to understand. Now it's 3 a.m., something's happening. Oh, let me open up my extended event viewer because I would totally not use Profiler. Somebody's passing in 24. Well, the code only passes in 25. That's the problem. But otherwise, we might have said, I think I see the problem. This code needs to run every time. So we have simplifying, getting rid of this junk, this cruft that has built up. Then, after we're done not hoarding, we have, after we're done not hoarding in an individual procedure, we can get rid of entire procedures that are not in use. Places where things are in use. Plan or procedure cache, if it's called in there, it's probably in use. SQL agent jobs, you can query sysjob steps. You can search in your source control system and see where it's in use. Integration services packages may be using it. And again, the BIML for that should be in source control. Notice how I just did a BIML thing right there. Sys.SQL modules has a definition column. So the definition column in sys.SQL modules, you can search through it for a call. And suppose you have a view and you want to know, is there anything using this view in my SQL code? You can search in there. These are just a few of the places that you can look. Unfortunately, there's no way of saying this procedure or this view is absolutely never in use. Instead, this is a measurement of risk. You may have other internal tables, like you've built a system that takes a bit of data and a bit of metadata and builds a process that executes particular procedures based on that metadata. These are types of places that you would know about, hopefully, but are particular to your systems. These are things that are built in typically with a SQL Server instance or in a development environment. The last bit that I'm going to hit, because Carlos is going to get the vaudeville cane and yank me off here, is modernizing code. On the small, look at stuff that's been in SQL Server for a little while and look at ways to try to get people to update versions of SQL Server. First thing is, we've had this date column since 2008. If you're doing this to get a date, you got an easier way of doing it. Now, arguably, you could say, these are technically different because I really want the time as well. All right. Whatever. I don't believe you, but... Second, concatenate. So prior to SQL 2012, to concatenate things, we had to worry about whether or not there was a null, whether or not this thing could be nullable. We had to worry about data types being different. So we explicitly casted numeric types, otherwise you get an error. And we have to put is null or coalesce around nullable columns because otherwise you get back a null string. Well, with concat, no problem. Just pass it right in, bam, 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 you get an end result. There is even a newer functionality in 2017 to work with strings even further, but I don't have an example of that here. I just have concatenate because this is pretty solid. I use concatenate a lot just to paste together strings. Yes?
What version of SQL Server is concat?
That was 2012 or later.
Wow.
Sorry, all you 2008 people.
Yeah.
You got date.
That's true. Date is available in 2008.
And on standard edition, you can compress your backups.
So another place where we can modernize, running totals. This does require 2012 or later if you want to do it the good way.
The good way.
We have some data. We have line items, sales orders, and sales order detail lines. So here we've got a bunch of orders associated with this particular order ID. So these 12 orders are all associated with the same order ID, 12 order lines. And what I want to do is sum up the value of each line in a running total. The best way to do it prior to 2012 is with a cursor. I had to swallow some level of respect for myself there by saying that out loud, but unfortunately it's true. And here's the cursor. And you can look at the cursor code if you'd like, but notice that it gets us down to nearly line 100. But it does give us our results. So we go from 2,000 to 8,100 to 10,000 to 12,000 and so on and so on. And then we reset with the new order.
Couldn't you do this with a group by and linking to the same table join to the same table?
You could do a self-join table, but with large tables, that will perform pretty miserably because you have to basically do another scan over and over and over of that table. There is a quirky update that it's historically been very contentious whether to use a quirky update because it's fast and it works in old versions of SQL Server, but it depended upon an irregularity that was never documented and could have changed at any point in time. Now, if you're using SQL Server 2008 R2 because you can't get 2012, they're not changing it anymore, so you're safe at this point. So I guess that's some measure of solace. But I don't necessarily recommend things that like any patch could break your update code. Here's the self-join that Randolph mentioned. The self-join does work, but once you start talking about millions of rows in a table, this will just collapse. As of 2012, window functions, sum over. Specifically, what 2012 offered us was this rows unbounded proceeding. So what we're doing is every row, we're looking at all of the previous rows before it, summing up to that point, and we get the value. Summing up to the point, we get the value. And what this does is, with one scan of the data, I'm able to build up my end results. These are cases where we're taking advantage of new functionality in SQL Server. We saw string ag. There's a string split function in 2016. Prior to that, I would have used a CLR method. There's trim instead of ltrim and rtrim. Like some of this stuff is small, trim is small. But there are bigger things, string aggregation, concatenation, running totals. Being able to do that quickly and efficiently is a pretty big gain. I have a whole section on increasing your durability and visibility. That's handling errors appropriately, logging errors to some log, logging performance to a log, so you can get information on whatever stored procedures are called. That's bonus material if you're interested in grabbing it. If you'd like to grab the code, the slides, links to additional resources, that's at csmore.info/on/legacysql. If you have any questions after the conference, hit me up via email or Twitter. At the conference, you can talk to my agent, Jonathan, and he will pass along the most interesting messages to me, whereupon I will respond to him because I don't actually talk to people.
You have people.
I have people for that, yes.
Somehow along the way, I became one of those people.
Somehow. SQL people. Thank you, everybody.